Okay, so now let's talk about electric potential energy. Now, electric potential energy, the definition is similar to your gravitational potential energy previously in gravitational field. In gravitational potential energy, our definition was work done in bringing the mass from infinity to that point, right? So electric potential energy is work done in bringing the charge from infinity to that point. And we also have this electric potential, which is similar to gravitational potential. Gravitational potential is work done in bringing unit mass from infinity to that point. So electric potential is work done in bringing unit charge from infinity to that point. Just change the mass to charge. Now, another major difference you will notice is this. Okay, I'm going to show you. Now, remember the formula for gravitational potential energy. So the formula will be U equals to negative GMM over R, right? So I told you last time you must include the negative here, because the negative shows you that all values of GPE must be negative. So why are all values of GPE negative? Because the GPE at infinity is 0. And whenever you move an object from the surface of the earth, let's say, towards infinity, means go higher and higher, you have to do work and you will increase the GPE to 0. So therefore all the values are less than 0, so all will be negative. But you look at the formula for electric potential energy, it's just QQ over 4 pi epsilon R. There's no negative in front, right? But for scalar quantities, which is potential energy and potential, we must keep the negative for the charge. That means if one of the charge is positive and one of the charge is negative, then you will substitute positive and negative, and what will happen to your potential energy? Negative, right? So why will your electric potential energy be negative? Because when one charge is positive, one charge is negative, the force is attractive or repulsive? Attractive, right? So if it's attractive, isn't it the same as gravitational field where they're always attractive? So same thing, if one positive, one negative charge, their forces are attractive, so you bring the test charge towards infinity, you will increase the potential energy to 0 at infinity. So therefore, all the values of potential energy will be negative. But there's a difference. If both charges are positive or both charges are negative, then when you substitute here, your potential energy will be positive. So electric potential energy can be both positive or negative. Whereas gravitational potential energy always negative. So why will your electric potential energy be positive? Example, if let's say you have two positive charges, the potential energy at infinity is still 0. That one doesn't change. But now, to do work, we don't bring them away, but we bring them nearer to overcome the repulsion. So that means if I bring the test charge from infinity towards the charge, I will have to overcome the repulsion. That means the potential energy will increase. So from 0, it increases. So therefore, all the values are positive. So therefore, you have both. And if you're talking about electric potential, now electric potential, right, is same formula as gravitational potential. You can take the potential energy, the W here, and divide by charge. So it means if I substitute this potential energy as QQ over 4 pi epsilon R, into here, the Q, small q will cancel. So I'm left with Q over 4 pi epsilon R. So the question is this. There are two formulas here, so what's the difference? So same thing. If the Q is the bottom, it is a test charge. The Q on top is the charge that produces the field. For example, let's say you want to find the electric potential of this gold nucleus at a point here. So if you're using this formula, we must find the potential energy of the test charge, let's say a proton, over the charge of the proton. But if you use this formula, we can straight away take the charge of the gold. Alright, and then we will find the potential of gold at this point. So, the definition, remember, so the definition will be these two. One is potential energy, one is potential. And it's the same as gravitational potential energy and potential, just change from mass to charge.